BIMxAR is an educational tool that supports the understanding of buildings through spatial learning. It utilizes building information modeling BIM, augmented reality AR, and physical buildings. BIMxAR uses 3D model-based deep learning registration for scale of buildings, in which the 3D model is a 3D scanning, corrected BIM model. It spatially superimposes BIM model on the physical building. The BIM model is rendered with a transparent yet occlusive shader highlighted with a green wireframe. This allows the users to simultaneously view the physical and virtual objects. BIMxAR enables users to retrieve BIM metadata of building components they are interested in. The first prototype is BIMxAR 1.0. It supports the learning and understanding of building construction systems, materials configurations, and 3D section views of complex structures. The section mode enables users to create section views and control the location and orientation of their sectional planes. The pivot enables you to understand the orientation of the BIM model in respect to the physical environment. The pivot represents the three axes X, Y, and Z of the BIM model. It becomes handy while controlling the location and orientation of the sectional planes. The orientation of the pivot is updated simultaneously in respect to the device's camera. The mixed reality mode is a novel visualization feature that enables users to understand the context they are in by rendering the context space behind the physical objects being sliced, so that the virtual context space becomes visible through the cut openings on the physical building. Also, the first prototype allows users to retrieve BIM metadata of internal elements inside building objects through the section poche. The second prototype is BIMxAR 2.0. It supports the learning of specific building construction systems using the BIM visualization mode visibility of categories in an AR setting. This visualization mode enables users to view and inspect specific building components in isolation from other building components in the BIM model. Each category is assigned with a different colored transparent occlusive shader and wireframe. The mixed reality mode renders the context space behind the physical building, so it becomes visible after the visibility of single or multiple categories are disabled, while the other physical building objects, where their visibility of categories are enabled, occlude the virtual context space. Also, it renders the shared faces between the BIM model objects with opaque textured shaders to enhance the visualizations of this mode. Also, the second prototype allows for BIM metadata retrieval of object of interest in isolation from surrounding categories. The third prototype is BIMxAR 3.0. It enables learning the layers or elements of building components and their assembly in an AR setting while maintaining the alignment of the virtual model with the physical building. The third prototype allows users to control the visibility of each layer or elements to reveal the hidden elements of the building objects being inspected. Also, it allows users to retrieve the BIM metadata of the revealed internal elements. Similar to the previous prototypes, BIMxAR 3.0 utilizes the mixed reality mode to render the context space behind the physical building. The proposed approach of BIMxAR was validated through a test case in which BIMxAR 1.0 was used as an intervention. 2 study groups were employed. To ensure a fair comparison between the groups, a non-AR version of BIMxAR 1.0 was developed and used in the non-AR group. The non-AR version was developed to be identical to the AR version in terms of the BIM example project and capabilities. The recruited participants were students from the Department of Architecture and Department of Construction Science in the College of Architecture at Texas A&M University. The test case used a pre-test, learning, post-test design to measure the participants' learning gain after the introduction of the intervention. Considering the short learning session, the findings show that the intervention contributed to higher learning gain. However, the learning gain differences between the groups were not significant. The overall workload associated with the AR version was significantly lower in the AR group. Also, the AR version was rated significantly higher in terms of performance. Observations in the learning sessions showed that students in the non-AR group tried to align the virtual BIM model with the physical building, which was difficult, while the students in the AR group conveniently utilized the automatic alignment between the virtual BIM model and the physical building, enabled by the developed AR registration method.